Okay guys, welcome back. This is an exciting video. Today we're going to bring together all of the pieces of our Lego functions and actually make our main function that's going to create our Lego data. So let's create a new function, and I guess I'll just call this Lego maker, sure, whatever you want to call it. And we're going to pass in our pixelated image. So let's call this pixel image. That's what we're going to pass in. And we can come back and document this code later because I'm still kind of thinking about how we're going to do this. But essentially, I want to return two things. I want to return we'll call this my Lego image. So it's the image that represents the, all the Lego colors. We want to put the correct colors on the correct block. And I also want to return what I'm going to call block data. So it's all the data that tells the user what color goes where, what's the Lego block number, what's the Lego block color. And we can use that for creating not just images and things, but we can also use that to make like a manual on how to build this thing if we actually want to build these kits. So the first thing we're going to do is we're going to create a blank NumPy array that's going to store our data. If you kind of remember, we talked about OpenCV and the format of an image's data. It's actually a NumPy array. So to create a NumPy array, let's call this our Lego image. And that's going to be np.array, or let's do zeros. We'll initialize everything to a value of 0. And the size of this is going to be the same. It's going to have the same shape as our pixel image, if that makes any sense. So we'll do pixel image dot shape. So the dot shape function returns the dimensionality of a matrix. So if it was a 3 by 3 by 3 channels because it's RGB, the shape would be 3, 3, 3. So in our case, we want to return an image that's the exact same shape as our input image. And we want to specify the data type. The data type is going to be a uint8, so an unsigned 8-bit integer. We want to make sure NumPy knows what type of data that's supposed to be. RGB values or BGR values are always stored as a unsigned 8-bit integer. So this creates kind of a blank image that we can use to return to the user. And what we want to do is we want to loop through our image. So for we'll say row in the range of the length of our pixel image. So basically, however long our row is, we want to iterate through that. And then we're going to say for column in range, and this is going to be the length of our pixel image, 0. So we take the first row, assuming there's at least one row in our pixel image, and however many pixels across that is, that's how many columns our output should be. So we're going to loop through all the rows and through all the columns. And what we're going to do is we are going to take the data. Well, first we're going to take our pixel value that we're on in our input image, and we're going to convert that into an RGB value. So the R value is going to equal our pixel image row column. So row column. So that's the pixel at a specific row and column that we're looping through. But we want to just get the last, because it's BGR as an input, if you remember. So we want to get the last item. That's going to be our R value. Our G value is going to be almost the same. I'll copy this down. Our G value is going to be almost the same, except that'll be in the middle at index 1. And our B value is going to be the first, because again, BGR. And we can say our pixel RGB is equal to RGB. Very simple. So we've just taken our pixel and created an RGB value. Now we want to take that pixel RGB and we want to use that to find the closest color, and we can use that by using our function that we used before. So we can say our match color is equal to best color match, and we're going to put in our pixel RGB value. So that'll give us our matching color. Now remember, our matching color is not just going to be the RGB data, it's going to have all of the data about the block. So the RGB data is index number 2. It's the third part of this. So what we want to do is we want to say our match color RGB value, that's equal to the match color in the second index, the third item. And finally, because we want to return our Lego image in the format of a BGR image again, so that OpenCV can work with that natively, we're going to take this RGB value and we're going to put it into the Lego image. So we're going to first access our Lego image at the same row and the same column. So this is going to take that specific pixel, and then we're going to say 0. So again, this is expecting a blue value here because we're going to output this as a BGR. So we want to put in our match color the blue value from our match color RGB. So that'll be match color RGB, and that will be index 2. We then want to take the green channel of our Lego image, and we want to set that to the green channel of our match color RGB. And finally, we want to take the red channel for our image and set this to the red channel. So you can see how these are flip-flopped. And now our Lego image has the correct data in the format of BGR. So we're going to return the correct image. So this part of our function is actually done. Now we want to return the block data. And the block data is not just the color information, but all the information, so that we can use that to build a manual. And what we want to do is we want to initialize a variable. Well, let's call it block data. What did we call it? Yeah, block data. And we'll set that equal to an empty list. So right now we have no data that we're returning. We just returned an empty list. And every time we create a row, we want to create a new empty row of block data. So every time we start looking at a new row on our image, we start with a new row of empty data. And what we do is every time we go through a column, which is a pixel, and we find a match color, we want to take this match color and append it to that data, to that row, so that by the time we loop through all of our columns, all of our colors have been appended to that row of data. So we can say our block row data, we can append our match color, which remember is not just the color, but it's all of the data. So it's this whole data object here. We can append that whole object on here. And then after we finish going through all the columns, and before we go to our next row, we want to take that whole row and append it onto block data. So we're going to do block data.append, and we're going to append the previous block row data. Then after this executes, we go to the next iteration. We create a new blank row of data. And then we start to populate that. Every iteration here, we append our colors onto that row. And then when we get to the end here, we append that row onto our block data again, and we keep going through. And by the time we're done, we'll have a nice list of block data. So let's go down here and let's start with a 3x3 image, just so we can take a look and see how this is going to come out. And I'll do let's do two things. We'll say our block image and our block data is equal to, what was the name of our function? Lego maker. And remember, we have to pass in our low res image, so that's our image low res. And that's going to return two things. So the nice thing about Python is we can return multiple things in a single return statement. And we can assign them just like this. So we can say block image comma block data equals this. This is going to return two things and they're going to be put in that same order. So it's very convenient. One function and we get an image and our data in one shot. Very convenient. First, let's show our data. So we'll do cv2.imshow. Let's put in our block data and let's do a wait key, cv2.waitKey0, so that we can display it. So let's see how this looks first. Let's see. Have an error in line 133. Oh, image show requires giving it a. I always do this. It's one of those things. I just can't break the habit. Remember, cv2.imshow requires a window name, so we'll just call this preview. That's the window name. Then you put in your data. I make this mistake quite a bit. And let's see. Oh, I passed in block data. I should have passed in my block image because that's not the data I want to pass in. I want to pass in the image to show. Let's try this again. Okay, and you can see that that's our Mario image in the format of 3x3. I don't know, it doesn't really look correct. We'll look at that in a minute. It might just be hard to tell because it's only 3x3. I also want to show you what the block data looks like. So just to make it more clear and legible, we'll say for row in block data, and this is just for display purposes, so we can see what that block data will look like when we get it back out. Let me close that so it'll execute the code. Nope, something went wrong. Let's run it again. Let me comment this out. I didn't hit a key. That's the problem. There we go. So you can see what we have is rows now. So in our first row, we have a blue, a yellow, and a yellow block. In our second row, we have a gray stone, a dark red, and another gray stone. So this will get very messy very quickly, but what we can do now is we can use this. This is almost a data structure that contains the block number, the block name, and the block color. All the data for making that design that you've created is now encoded in this object. And we can use this for not just displaying information to the user, but we can now generate an entire assembly manual and work instructions and parts count and the number of blocks you need to buy. So we can use this data structure for all of those things to actually make a real Lego kit. So it's very useful. That's why we did it in this way. So let's make this bigger. I'm going to get rid of the size constraint now. I'm not going to print this anymore because it's just going to be a big mess on the screen. That was just so you could understand the data structure and the importance of that data structure. Let's change the scale ratio to, I'll use this. You can use whatever was working for you. Oops, I've got the Lion King on here now for some reason. Let me do Mario, because that's what I've been working with. And instead of imshow, because it's a little bit harder to show on my screen, I'm going to do cv2.imwrite, and I'll do output.png block image. I'm going to write it to the disk because then it's a little easier to show you guys. Okay, output.png is here. And you can see we get our nice Mario picture, nice color, so it does look like it's working properly. Let me try to make the size bigger. Let's go to like 0.15, so it's a lot bigger. And let's see, how does it look when it's done? There you go, it's bigger. And we get a really nice Lego kit here for Mario. And let's take a look at the Lion King. Just for fun, see how that looks. There you go. We get a really nice image of the Lion King. This one really looks cool. When you get close, you get all these different colors like greens and pinks, but then when you look at it at a little bit of a distance, you get that really nice mosaic effect. This would be an excellent kit to make and hang on your wall in your house. So congratulations if you followed along this far. You've basically, you have now a working tool for generating Lego mosaics using real Lego colors, and you now have a data structure that you could work with to build a Lego kit and instructions. That's something we will look at in a future video, but you should be very proud of yourself. Play around with it, make some images, and show your friends and family. They're going to be really impressed with what you've made. So again, congratulations, and I hope that you enjoy the content. Please consider liking and subscribing to my channel. I would appreciate that. And I look forward to seeing you in the next video. Have a great day.